If we're going to make some predictions on how reactions work, we need to be able to identify Lewis acids and Lewis bases. And it shouldn't be any surprise at all that the underlying principle in all of this is that areas of positive charge interact with areas of negative charge. The idea of positive and negative works even when we have neutral molecules. We think of it as areas of positive charge interacting with areas of negative charge. Even if we have a neutral molecule, there may be regions or specific atoms in the molecule that have greater electron density, and other regions or atoms that have less electron density. Another way to think of it is that an atom that is electron deficient on one molecule will interact with an atom that is electron rich on the other. The electron deficient atom would act as a Lewis acid, not contributing electrons to the new bond that forms. The electron-rich atom would act as the Lewis base, contributing 2 electrons to the new bond that forms. But what should we look for to identify a Lewis acid or base? First, cations are clearly electron deficient, whereas anions are electron-rich. So cations are usually Lewis acids, whereas anions are usually Lewis bases. But it doesn't have to be full charges. Partial positive or negative charges in a polar bond will leave the positive atom electron deficient and the negative atom electron rich. There are 2 other characteristics that can help us identify Lewis bases. First, lone pairs. If a Lewis base donates a pair of electrons to a new covalent bond, a lone pair would certainly be available for donation. Second, multiple bonds, either double or triple bonds. As an example, a double bond consists of 4 electrons, but really only 2 are needed to keep the atoms bonded together. The other 2 could be available to form a new covalent bond to a different molecule. Knowing what to look for helps us to spot where 2 different molecules may bond together.